Hello students, today I will explain you one problem on design of knuckle joint. So here is the question. Design a knuckle joint to transmit 150 kilonewton. Design stresses are taken as 75 megapascal in tension, 60 megapascal in shear and 150 megapascal in compression. So first of all, we will write with the given data. And as it is in megapascal, it is in Newton per mm square itself, and load will be taking 150 into 10 raised to 3 Newton. First step is to find the diameter of rod in, that is considering tensile failure of rod. So students, as we know the strength equation of the rod in tension, P is equal to pi by 4 d square into sigma t. Let us substitute values of P and sigma t. So the unknown is diameter of rod. So we have found the diameter of rod which will resist the tensile failure, and the answer is 50.4. Say for a safer side, we'll be taking it as 52 millimeter. Next step, second step is empirical relations. In empirical relations, we will be calculating all other parameters by taking diameter of rod as reference. So we will be using this relationship. Inner diameter of eye D1 is equal to D is equal to 52 mm. Outer diameter of each eye 2D is 104 mm. Diameter of pinhead and collar is 1.5 D, so it is 78 mm. Thickness of single eye is 1.25 D, so it is 65 mm. Thickness of each eye of forked end is 0.75 D, so it is 39 mm. And thickness of pinhead and collar is 0.5 D, which comes 26 mm. So after finding all the parameters, now we need to check design of knuckle pin, design of single eye, and design of forked end. So first of all, we will check design of pin in double shear failure. So strength equation of pin in double shear failure is P is equal to pi by 4 2 into pi by 4 d1 square into tau. There we will be finding shear stress induced. So let us substitute values of load and diameter of pin, and we get here shear stress induced as 35.315 Newton per mm square. We can see that our stress value is less than the permissible value. Therefore, design of pin is safe in shear. Now, failure of single eye in tension, and that we have to consider across the whole. So, when we consider the tensile failure of the single eye across whole, the strength equation is P is equal to D2 minus D1 into T into sigma T induced. Substitute values of P, D2, D1 and thickness of single eye. We will be finding now induced tensile stress. And students, we can see that it is 44.37 Newton per mm square, which is less than permissible value. Therefore, design of single eye is safe in tension. Next, we will be considering crushing failure of knuckle pin in single eye. Step number 5. As we know, strength equation of crushing of knuckle pin, P is equal to D1 into T into sigma C induced. So here we will substitute values of P, D1 and T, and we can find sigma C induced. Here we get sigma C induced as 44.37 Newton per mm square, which is less than permissible value of the crushing stress. Therefore, design of single eye is safe in crushing. Now, failure of single eye in shear. So, due to push by the pin, end of the single eye will be sheared off, and that will be double shear failure. Strength equation: P is equal to 2 into d2 minus d1 divided by 2 into T into tau induced. Substituting all the values of P, d2, d1 and T, we have calculated that shear stress induced is 44.37 Newton per mm square, which is less than permissible. Therefore, single eye is safe in shear. Now, friends, similarly, we will check double eye for various failures. So, first we will see fogged end in tensile failure, that too across hole. And because it has two eyes, so strength equation is P is equal to 2 times d2 minus d1 into t1 into sigma t induced. Let us substitute all values of P, d2, d1 and t1 because thickness of each eye of a forked end is t1. So here sigma t induced is 36.98 Newton per mm square, which is less than permissible value. Therefore, design of forked end is safe in tensile failure. Next step is failure of knuckle pin or fogged end in crushing failure. And there will be localized compressive stress at the contact area, and because there are two eyes, so strength equation for crushing failure of pin in fogged end, P is equal to 2 times d1 into t1 into sigma c induced. After substituting the values of P, d1, t1, we can easily find crushing stress induced in the pin, and here it comes 36.98 Newton per mm square, which is less than the permissible value. Therefore, design of knuckle pin is safe in crushing failure. Next, we have failure of forked end in double shear failure due to push by knuckle pin. End of the fogged end eye will shear off, and there will be a double shear failure because two areas of failure are there. And there are two eyes also. So strength equation is P is equal to 2 into 2 into d2 minus d1 by 2 into t1 into tau induced. Substituting all values here, we can find shear stress induced in the double eye, and it comes 36.98 Newton per mm square, which is less than permissible value. Therefore, design of a forked end is safe in shear. Now we will see 10th step, which is failure of knuckle pin in bending. So we will use formula of bending stress is equal to M upon Z. As we know that maximum bending moment equation for a pin is P by 2 into T1 by 3 plus T by 4, and section modulus for pin is pi by 32 D1 cube. Let us substitute value of permissible tensile stress here and values of P, T1, T, and remaining terms are constants. So we get minimum diameter of pin we should keep to avoid the bending failure. So friends, here when we want to avoid bending failure, minimum and safe diameter of pin should be 66.78. So we keep 68 mm. And in third step or second step, we have taken diameter of pin as D1 is equal to D is equal to 52 mm. That diameter of pin is safe in shear failure, but 52 mm diameter of pin is not safe in bending failure. So friends, to avoid the bending failure, we must increase diameter of knuckle pin from 52 mm to 68 mm. Thank you very much, students. Okay, thank you.